this is where we left off. And so I'm going to proceed from there. So if you need to get data and store it in an element of the array. So if num is an array declared already, I want to store the value entered by the user into that, or I want to print that. All those can be done this way. Just simply see out num6. Just like any other variable, I can see out num6. That means I'm printing the 7th element of the array. I can ask the user to enter a number, and I can capture that in the variable num1 by writing C in num1. So what I'm trying to say is you can use all these elements of the array just like any other variable. You can do that. But ordinarily, we do the processing of the array in a loop. So we don't normally write this kind of C in, C out. Normally, even if you want to write the array, you don't write part of the array. Normally, you have to write the entire array. So you normally use a loop to write the entire array. Those things are coming up later. I just wanted to point out one more thing. I can actually refer to num parentheses an expression. In the bracket, I don't have to always have a number. I can write an expression. If I write an expression, it will evaluate the expression and use the value. So here I use 2, and therefore 4i minus 2 will be 8 minus 2, 6. So this is referring to num6. It says see out num6. In some programming problems, sometimes you have to do expression like that inside the bracket, which is allowed, valid. All right, so another example. Can I assign data as I declare, like we did with the variables I'm writing on the board? Remember, we have been doing int num equal to 5. You declare the variable and assign a value. Same thing with the float. Can we do that with the array? Yes, that's the point I'm making next. If I want to store these values in an array of size 7, then I can say int num7. This part is declaration of the array. And this number 7 inside is the size of the array. And equal to, I had to put all the values in brackets. And if you declare the size to be 7, then you had to have exactly 7 numbers. Then 15 will be the first, 15 will be stored in the first location of the array, first element, 20 will be in the second element, and so on. All right, now if you are doing this, if you're assigning 7 numbers to the array, that's the only time it's okay not to write the number in the bracket. See, the bracket is empty in this second example 8. And you can do that only in this situation where you are assigning values to it. Then the compiler can figure out the size by counting these 7. So it'll automatically make the array of size 7. That is acceptable. And that's the only time you can have an empty bracket. The bracket otherwise has to have the size of the array in the declaration. Only in the declaration it will be size of the array. So like if I'm writing if I'm declaring an array, I have to say int num and then 7 inside the bracket. That's a declaration. It says num is an array of size 7. And then later when you use the array, instead of 7, you'll be using 0, 1, all the way to 6. 1 less than 7 will be the subscript values when you're using the array. Okay, now here's another example. I want to declare an array for storing vowels. And so I declare char vowels and then assign all the vowels. So since I'm assigning the data, I don't need to put a number in the bracket. The bracket can be empty. Another example, is it okay to declare an array of size 7 and assign only 2 numbers? Yes, it is valid. And if you assign only 2 numbers, then these 2 numbers will be going into the first 2 elements of the array, and the remaining elements will be zeros. All the remaining elements will be zeros. Now, so that means if I just assign a 1, 0 to the array, then the remaining elements will be 0. And so that's how you assign 0 to every element of the array. You know, sometimes you need to initialize the array with zeros. Then you do it this way. Just assign 1 0. That's all you need. You don't have to write this 0 7 times. I mean, here we are dealing with array of size 7, but in reality, the arrays are of size, 500, 1,000 in real life problems. So you don't want to type 500 zeros. So that's why the language allows all these nice features. This example is unimportant. Moving on to 6.3, using arrays, how to use arrays in the program. So we have been just talking about how to declare an array, and also we learned all the facts about it. Now we'll see how to use them. So very often in programs, you use loop to manipulate, because one loop containing just 3 or 4 lines can process the entire array of size 500. Because whatever we normally do, we need to do to all of the elements in the array. So that can be done in a loop. That's the easiest way to do it. Okay, so here's an example. I want to assign the numbers 1, 2, 3, 4 all the way to 20 to an array of size 20. So just the numbers, integers from 1 to 20, I want to store them in the array of size 20. So I declare the array of size 20. Now, always when you use an array, you need a subscript variable I. Always, there's no other way. So you introduce a subscript variable, integer variable, and then for I going from 0, the I is subscript. When I is 0, this num I here is referring to num 0. That's the very first element of the array. So num 0 will be 0 plus 1, according to my program, which is 1. So num 0, which is very first element of the array, is getting 1. So let me put it on the board here. So my array is of size 20, and this very first element now has 1. And then the I increases to 2. I mean, sorry, 1. When I is 1, I less than 20 will be checked. And num1, I is now 1. So num1 is getting 1 plus 1, which is 2. So now we have 2 in the second element of the array, and proceed to increase the I to 2. And when I is 2, num2 is assigned a 3, 2 plus 1. So num2 is getting 3. Now this is num0, this is num1, this is num2. Remember, the subscripts have to go from 0 to 1 less than the size of the array. So that's why the I is going from 0 to I less than 20. See, less than 20 means it'll go up to 19. Do not ever go beyond the size of the array. If I put I less than or equal to 20 here, less than or equal to 20, then I'm allowing 20. And there is no element in the array with the subscript 20. And that's an error. And compiler will pick it up. And the program will not run. So you have to pay attention to that. I must be less than the size of the array. So always write I going from 1 to less than the size of the array. Then it'll be easier. If you put less than or equal to, then it has to be size minus 1, like this. If I say less than or equal to 19, then that's correct. But it's much easier to just simply remember to always do less than the size. Then it'll be, you won't forget it. Just use the one method. Okay, now next example says, an array is declared as float val 100. So it has been already declared. You need to write statements to replace each element of the array with the square of the original value. So replace every element with a square. So the array already has a value. That's what it means. So you only need to write the statement that will replace every element with the square of original value. So I going from 0 to 100. The for loop is always convenient because you know exactly where I should begin and how far I should go. and the subscript, is going to increase by 1 each time. So almost always a for loop like this will be useful to handle the entire array. For I going from 0 to 100, I plus plus, val I times val I, that's the square of the original value, going back into val I. So val I is replaced with val I times val I. That's all we need to replace entire array. This will replace entire array with the square of every element that it already has. And the array size is 100. So as you can see, this two-line loop will do the entire array. Next problem says array declared as char val 100. It says the array has been declared. So when the problem says something like that, do not declare the array. You only need to write the statement that the problem asks you to write. Write statements to count how many punctuation characters are found in the array. That's our question. So I just need to count the punctuation characters. So I need to say for I going from 0 to 100, I plus plus. And then inside, I need an if. This needs to be indented somehow. That was incorrect. If val I, always write val I, but I is going from 0 to 100. So all those different i's will be taken care of. Take the val I and compare it to period, comma, colon, semicolon, everything. I mean, this list is going to be longer, but we can just write a few. I mean, it's understood because we are only just practicing. If it is actual program, you have to actually write out all the punctuation characters. So if it is one of those, then increment the counter. Count was set to 0 up here. So if this is true, then count will go up. And that's all I need to do in the loop. After the loop, this will be executed where I'm turning the count. If you have any question, feel free to interrupt. Okay, now let's use array for an application problem. Write a program to store the grades of students which are given to you. So the grades are already given to you. So that means we can write the program to actually store these data directly. We don't have to get them from user. And then count how many students get A, how many students get B, and so on. Okay, so here is the program. In the main program, I need to declare the grade of size 15 and assign all of the data directly to it. But that's what the problem expects. It gives you the data. Now I need to count, I need a subscript always, right? When I'm working with array, always need a subscript. And it's a standard practice to use I or J, K for subscripts. That way, any reader will know when you declare an I or J or K, that's going to be subscript. And, it's kind of customary in the programmer's world, but you don't have to follow that. So I is declared as a integer here to be used as subscript. And then I need to count all the A's in the class. So that'll be A count set to 0, B count set to 0, and so on. So set all those counters to 0. And then loop. Loop will take care of the entire array. So for I going from 0 to 15, I plus plus, take a look at each grade. And if it is over 90, then increase A counter. Else if, you need else if structure here. Only if it is not over 90, then it'll come to else. That means it's already under 90, and I'll only need to check against 80. It's already under 90. So now, if it is over 80, then it is B, and increase the B counter. Else if grade is over 70, then increase D counter. If it is over 60, D counter. Else. This else will be executed only if none of the above is true. And that's when we know it's F. So increase the F counter. And after that, you just have to write those counts on the screen. That's all you need to do. Okay, now example 5, write a program to obtain 30 floating point numbers, which are the daily sales of a business for 30 days, store them in an array, and to compute and print the average sales. So here it says the number of data will be 30. So we can assume the size of the array is 30. If you don't know how many data are going to be stored, then we have to handle it slightly differently. That's coming up later. Uh, I believe it's in this section. Anyway, here is 30 numbers coming in, so therefore I can declare the array to be size 30, and then I also need to compute and print the average sales for the month. So I need to add up the entire array. We'll do that in the next step. Float sales 30, that's sale 30, that's my array to store all the sales. And then tot sale is for the sum of the sales numbers. And then average, that's set to 0 initially, and average is where average sales will be stored. Now for I going from 0 to 30, I ask for the sales. I need to get the data from the user now. We don't have the data available. So C out into the sales and C in sale I, that loop right there takes care of getting 30 data from the user and storing in the array. Notice that when I is 0, it's asking for the data and storing it in sale 0. Then the I increases to 1 and it's asking for the data again. And now the data is going into sale 1. When then I changes to 2, it asks for the data again, and the data goes into sale 2. So we are putting it in different elements of the array. So when this loop finishes, 30 data have been stored in the 30 elements of the array. Now I need to add them up. So I can start another loop. For I going from 0 to I less than 30, tot sale equal to tot sale plus sale I. That's it. That'll add up entire array. So like I said before, use a loop, then 2-line loop takes care of all the data stored in the array. Now, can I write this in the first loop? Yes, you can. In this case, we know that there are exactly 30 data, but if it is central control loop, then you don't want to do that in that loop. So this statement, if I copy this and put it here, will that be okay? Let me do it again. If I put it there, then right after getting the sale, I'm adding it to tot sale. You can see that that'll work, right? Then I don't need the second loop. You get the data and store it in this element of the array. Immediately after that, you add it to the tot sale and put it back in tot sale, and that will be also correct. But I wrote it the other way just to make it clear. It's okay to do it either way. And the average statement is outside the loop. We cannot do the average until the loop finishes, and only when the loop finishes, this will be executed the way it is written. Only this one statement is inside the loop. That's why I don't have brackets. So this is outside the loop. So when the loop ends, tot sale is done, and that's when I divide it by 30 to get the average, and then print the average. So that's how arrays are used in programs. So let's go to the next one. Here it says, write a program that obtains 40 integers from the user, stores them in the array, and then computes the average and the maximum. Okay, average and maximum. So here's the array, num of size 40, and sum is for the average. Max is to store the maximum. Now declare float average for storing average. Now for I going from 0 to 40, you ask the user for the number and see in num_i. That loop will take care of getting all 40 data. So 40 data have been stored in the array now. And next thing I need to do is for I going from 0 to 40, sum plus equal to num_i. That will add up the entire array. I going from 0 to 40, I'm adding every element of the array to the sum. And when that finishes, this is outside the loop, I can divide the sum by 40, store it in average. Now to find the max, now we learned the technique already before, and we used it for smaller collection of data before. Now is the time we apply it to large number of data. There are 40 data here, and we need to find the largest of those. And we can simply do the same way we learned before, the technique we learned before, which is copy the very first number into into the max. In this case, it's num0. And then for I going from 1, now I goes from 1 because num0 is already taken care of. I copied that into max. Now I goes to 1, I goes from 1 to 40, less than 40, I plus plus. For all those i's, comparing num_i to max. Whatever max has, you compare it to the next element. If the next element is bigger, then copy it into max. So just do that in the loop. Then when this loop finishes, max has the maximum. So write the average and the maximum. Now, could I have done these matters in the first loop where I received the data from the user? I could have. I could have done this sum equal to sum plus num_i. Also, the max business could have been done there. To do that, the max equal to num0 is not valid if I do that here. So let me go back to that part. If I want to do all that work in here in this loop, then I have to start the max at something. If I know the numbers are limited to positive numbers, then I can start max at 0. Then, because I don't have the num0 available at this point. If I want to do it this way, if I want to do all the work in this loop, then I have to do it differently. Start the max at 0. Now, starting max at 0 is not advisable. In that last project that was given to you, the last project means the project 4.5.1, you were told to use 0 for max and very large number for min to begin with, to make it easier for you. I did that. But remember, when you write a program, you don't know what the actual data are. So if the numbers are allowed to be negative, then this starting max at 0 is going to be wrong. There will be some numbers smaller than that. That will be, all the numbers may be smaller than this. So then the max will be completely wrong if all the numbers are smaller than this. So we don't know the data. That's how you have to assume. You have to assume that we don't know what the data, the size of the data is. So you cannot assume that you can take 0 as the initial maximum. So the best method is to use the very first data as the minimum or maximum, and then compare everything else to that. That's the right way. Doing max equal to 0 is only acceptable if you know that the numbers are bigger than this. So I do that, and then I put the if statement right after getting the num_i. I can say sum equal to sum plus num_i, and also I can say if num_i is bigger than max, then max equal to num_i. Copy the num_i into max. All that can be done in this loop, but then I have to do this before the loop begins, which is not quite right. We don't know about all the numbers. We don't know that all the numbers are positive. Anyway, that's just something I wanted to explain there. But the way I have done it here is the right way. Or you can actually do both of these in one loop. No harm done with that. You can do the addition of the nums and also finding maximums all in one loop. That would be perfectly correct. Okay, moving on. Feel free to ask questions if you have any. So that finishes that, and your assignment link is already up, and it shows that you need to do 6.2, 3, and part of 6.4. So I'm moving to 6.4 now. I'm sorry, 6.4 is going to be skipped. It is a topic that is sometimes necessary, but it's not really very important, and so I'm skipping to be able to cover 6.4 and 6.5 and 6.6. Two more sections left to go over. Uh, so let me, oops, I thought I had it open. I don't. Okay, 6.5. By the way, I know now exactly when we can have our third exam, and it's going to be May 17, which is also the last day of classes. May 17th is the third exam, which is what, 2 weeks from today? I think so. And the test will cover the last part of section 4.5. If you remember, a portion of 4.5 was not covered in the previous test, and that's basically the sentinel control loop stuff. And so this test material starts there, the sentinel control loop, uh, and and then chapter 5 and 6, entire 5 and 6 will be covered.
Can we, is the review sheet relevant to test number 3 that you have
Yeah,
on Blackboard? Yeah.
yes, it is on
Okay.
Blackboard.
So we can look at the test review 3 and go over 4.5, starting from 4.5 all the way to 5 and 6, right?
Yes, I can even tell you what page to begin. The 4.5, latter part of 4.5, that begins at accumulation of data obtained from user, which is page 140. So you can make a note of it. Page 140 is where accumulation of data obtained from user begins. That's where the test material begins.
Okay, 140. All right.
And from 140 to all the way to end of chapter 6.
Under chapter 6. Okay.
Yeah. Chapter 6 goes to 6.5, 6.6 is the last section of chapter 6. Okay, so let's do the 6.5, which is passing arrays to functions. Now, that's a very, very common thing to do in programming, very, very common. Because if you have very large number of data that you need to manipulate, you are using an array. And when you manipulate arrays, using functions is a very common practice. And so you need to pass an array to function very commonly. So for example, so let's look at this example. This is an array of size 4, and I'm storing values, these numbers. And then I want to add up all the numbers of the array. There's a function that adds up array. So if there's a function that adds up array, then I want to be able to call that function add up and pass the array. When you pass the array, you only need to pass the name of the array. You don't pass the bracket. There will be no bracket, only num. Examples are coming up. This is just to show you, but just passing a name of the array is not good enough. So when we get to the actual example, you'll see. So the function that adds up an array, the header of that function will look like this: int add up, and then in bracket int. To receive a value, you need to declare an array, and that you do right in here. The parameter of the function. The parameter of the function means the variable in which the value will be received. That's what we call parameter. And if there's one item being passed to this array, this function, which is an array. So to receive the array, I have to have an array. So you declare that array as a parameter by saying array ARR with a bracket, empty bracket. You need that empty bracket to tell the system that this is an array that's being received. So if this is your function call, then this num is being passed on to ARR. But when you receive at the header of the function, you need the bracket next to it. But when you pass the array, you don't put any bracket, just the name. And why that works is coming up. I'm going to explain when we get to the examples. Okay, so let's move on. So arrays are passed by reference. That's the point you need to understand. Now, we learned about passing by reference in the last class. Passing by reference means passing just the name, passing into another name. In other words, the value, you're not sending a copy to the function. You're sending the, you're telling the function to access the original memory by passing into a reference. So you saw that in the last class. We received, okay, let me write on the board. If I call a function by writing, let's say add up, whatever the name is, and pass a val to it, and if the receiving function add up has int and num, then the num becomes a reference to val. So val already has a value, let's say 15. Then what you're doing is by passing val into this reference, you're saying access the val, original memory val, by using this name. Or in other words, make this num another name for that val. So then num becomes another name for the same memory cell where that was represented by val. So now the same memory cell is represented by two names, val and num. So within the function, everything you do with num is actually doing to val. And then when you return, you come back to the main, the val still has, if the function may have modified the val. So whatever val has, you can print it or whatever you want to do here. So you're giving access to the function, the access to the original memory instead of sending a copy. So that's what's called passing by reference. And arrays are passed by reference, which means when you pass an array to a function, you are allowing the function to access the original array, not a copy of it. And that's the only way array will be passed. That's the reason why the language is designed that way is arrays are usually large, like 200 elements are there or 500 elements are there. So if you need to send a copy to the function, then another 500 memory cells will be used to make a copy. And that's a waste of a lot of memory spaces. So programs will be very inefficient if you do that. So the language basically blocked off doing that completely. So you cannot pass by value. You can only pass by reference. In other words, when you pass the name of the array, you're telling the system to access the original array. So all you have to do is, if you don't want the original array to be changed by the function, you have to make sure that the function doesn't change the original values. It will use the values, but it won't change. That's your responsibility to make sure that's how it works. And if the function actually changes the original array, then it's changed permanently. And in fact, it is sometimes useful to do that. For example, let's say I want to have I have a list of data which are grades in my class, and I have them in an array, and I want a function to rearrange that array to have them in increasing order. It'll be convenient if the function actually rearranges my original array. I don't need to save the original array. I just need to have them rearranged. And if the function is given access to the original array, it's convenient. The function will be rearranging the original array instead of rearranging a copy of it. If it rearranges a copy, then we have to receive that copy. And so there will be a lot of going back and forth with arrays and copies of them. It's all unnecessary. That's why the language is designed to receive array by reference only. So that whenever you want to modify the array in the function, you can do that. If you don't want to modify the array in the function, you can do that too. So it's up to the programmer to take care of all that detail. Okay, so that's how arrays are passed. So let me go to the, we'll do an example to see how the passing is going to work. Now, if you're passing it by reference, then here is what's going on. Let's say I have an array. All right, I'm drawing a little picture of an array. And this array has some numbers, 75, 95, 54. All right, see, these numbers are there. And this array is called num. So let's say the name is num. And my pencil is, all right. So let's say the name is num. Um, now, I'm trying to explain, I'm going to explain how exactly the arrays are passed to functions. It's very important to understand that. In the actual memory, um, every memory cell has an address. So the addresses are numbers. They're not integers. They're integers, but in hexadecimal coding, and you don't want to look at those numbers. But memory cells have addresses, just so that the system can function better. It needs to know, like each one of us has an address, so that the mail can come through, and also people can find us and things like that. So same thing is going on here. Every memory cell has an address, which is a number, and the system uses that number to identify it. And working with these memory addresses is also something programmers have to do. And that's actually the next chapter, chapter 7 in the book, working with the memory addresses. And that's a topic of 272 for those computer science majors. But I need to explain that idea here because it's important for understanding how the arrays are passed. So let's say the address of this first memory cell is 171. I'm just making up numbers. The numbers are larger than this, and they are hexadecimal coded for a certain reason. And second memory cell is, let's say, 172. Third one is 173. So each memory cell has an address. So num is the array, and when you store the numbers in that array, they are stored in beginning at certain cell, and the beginning cell has address 171. I just made that up. And when you pass the array to a function, so let's say function add up is receiving the num in an array. So int a bracket. A is the array that's receiving num. Then what you actually pass is this address. You're not passing the numbers. You're only passing this address to go into this name, A. So A has the address 171. So when you're referring to the elements here, when you refer to A0, it identifies A0 as the memory cell with the address 171. And so if you say S or sum equal to S plus A0, it's adding the memory cell 171, the content of the memory cell 171 to S. And then if you say in another line S equal to S plus A 1, then it's adding 1 to 171 to get the memory address. This one is added to 171 to get the memory address, and that's 172. And it'll get that next number, the number in the 172 memory. So this is referring to some memory cell 172, and you're adding that to S and putting it back in S. So that's why the subscript values begin at 1, 0, and when it is 0, you're referring to the actual original memory cell, the very first memory cell. When it is 1, you're referring to the next memory cell. And so that's how it works. So how does it know where this array ends? No, you're only passing the initial address. The address of the beginning is the only thing you're passing to the function. So the function doesn't know where it ends. So when you write the loop that adds up all the elements, you need to know where it ends. So therefore, you have to pass the size of the array. You need to, so you're only sending the beginning of the array. So therefore, you need to also say where it ends. So that's by passing the size. So passing the size of the array is necessary when you're passing an array. As you can see, when you pass an array, you're only passing the address of the beginning of the array. That's not enough to write your loop in the array. The loop has to say go from here to here, and so you need to know how many elements are there. So always when you pass a function to pass an array to a function, you pass the name of the array and the size of the array, two things. All right, so let's write the function add up to receive an array of integer type and add up the values stored in that array. So function add up must receive the array in an array and then the size in another integer variable. It needs to receive two things. So here is how it works. Here's the function add up. Let's begin with that. It has in the header, it has int arr bracket, empty bracket is necessary to tell the system that this is an array. And then in size, I must receive the size also. Then I say my subscript variable starts at 0, sum is starting at 0 because I'm going to add up all my array elements to the sum. So I say for in the loop for I going from less than or equal to size minus 1 or I less than size. I starts at 0, goes up to size. So you can either say I less than size or I less than or equal to size minus 1. For up to those, sum equal to sum plus array I and I plus plus. That will add up all of them. So to properly end the loop, I need the size because this ARR has only the address of the beginning of the array. And that's what I'm showing here. The 12, 9, and 5, 7 are stored in some memory. And whatever the memory is, the address of that very first cell, which is in this case 3458, that is what the name of the array has. The name of the array has always the address of the beginning of the array. The name itself is going to be holding the address of the beginning of the array. The variable that hold address of the beginning of the array is called a pointer. The pointer type variable. Those are explained in chapter 7. So the num, the name of the array, becomes a pointer which has the address of the beginning of the array by default. That's how it works. So the num has the number 30. So let's go to the function. So in the function we finished, we add up all the numbers by writing this loop. And when the loop finishes, I return the sum. Now let's go to the main. In the main, I assign my data to the num of size 4. And then see out sum equal to find the sum, I call the function add up and pass num and the size 4. I have to pass a number to go into the size. The size is 4. So the num, when the num is passed on to ARR, ARR is getting the address of the beginning of the array. That's all you're doing. You're passing the beginning of the, in other words, ARR is another name for num now. You can say that. So when you pass the array, the name of the array num is being transferred to the name ARR. So you can say ARR becomes another name. In reality, in talking in terms of pointers, the array ARR is another pointer that is receiving the address of the beginning of the array, which is 3458 in this case. But it is okay to say that ARR is another name for the array num. So when you refer to ARRI here, you're referring to ith element of the original array num. So you're adding the original array to some and increasing I and all that. So this is all accessing the original array. You're not sending a copy. Now, let me ask you a question. If I do array 0 equal to 15 in the function, if I actually make that statement somewhere in the function, does that mean I have changed this 12 here to 0 or not?
Not 100% sure.
Yes, we have changed
Yeah,
it
right. Okay.
because the function has access to the array, right?
Oh, okay.
Right. But when we did this with the variables in the past, the if function has a variable name array ARR that is receiving a value that num is holding, then only a copy of num is passed into ARR. So if you change the ARR here, the values of the original num doesn't change. That's why when you pass by value, you're only sending a copy. Only the copy is being used by the function. But here it's not. We are sending access to original array. So if the function modifies the original modifies array ARR, it is modifying num. Okay, so you need to make sure the function doesn't do that if you don't want to lose your original array. Sometimes we don't care. We don't have to keep our original array. But if you do need to keep the original array as is, then you need to make sure your function doesn't change it. All right, moving on. More examples. Here is a example that says, write a function odd count that receives an array of int type and counts the odd numbers found in the array and return that count. So it needs to count how many odd numbers are there in the array. That's all the function will do. Okay, so let me begin with the function int odd count, int array bracket. Array is receiving the an array, and then size is received in this variable size. And I'm counting odd numbers in the array. So I need to say count equal to 0 first. Any counter you use must be initialized to 0. And then for I going from 0 to size -1, I plus plus, if array I modulus 2 is not 0, then it's odd, right? If it is not divisible by 2, then it is odd number. Only then you increment the counter. So you, in the function, you're working with the this name array, but you are actually working with the original array, these numbers. You are not getting a copy. You're actually working with the original numbers. And here, I'm not changing the array in any way. I'm only counting how many odd numbers are there. And then I return the count. And let's write the main program now. Since I have written my function at the bottom, then I have to write a prototype at the top. That's this. Prototype will be odd count. Notice that int bracket, that's all I have, instead of the header, which is int array bracket. The names will be dropped. To make the header, to make the prototype, you take the name title of the, I'm sorry, the header of the function, the first line of the function, drop all the names. That becomes your prototype. So write that at the top. And then function, in the main program, I have odd is a variable to hold the odd count, and B is an array of size 16 with these numbers stored. Now, when I call the function, I call function odd count, pass only the name here. Remember, no matter how much I say, some students will be passing something like this. This is a very common wrong thing to write, B bracket 16. Think about that. What is B16? That's referring to 16th element of the B, right? Actually, 17th element of the B. There is no 17th element. The subscript is supposed to go from 0 to 15. So you're writing B16. That's invalid to begin with. There is no element in the array called B16. So this will be error. The program will not work. The compiler will pick up that as an error. And so make sure you don't do that. You just write a name only, the name of the array B, and then size of the array has to be passed separately. So the name of the array is getting received in this name. So this name becomes another name for that same array. And then size is getting a copy of 16. Size is only getting a copy of 16. That's not passed by reference. That's passed by value. Size is getting 16, a copy. And then this loop goes from 0 to 15, size -1. For all those numbers, all those subscripts, array I modulus 2 is checked. And if it is 0, then counter increases and so on. So that's how you work with functions receiving arrays. You pass only the name, but at the receiving end, you need a name of the array with a bracket behind it. Only then it recognizes that as an array. In fact, it's a pointer. And this is a variable to receive a copy of the size. Okay, so warm-up exercise. Write a function called LSUM that receives an array of integers and its size and returns the sum of the last digits of all the numbers found in it. You can call the function LDigit to find last digit if you like, or if you want to directly find the last digit by doing a modulus operator, that's fine. Either way is fine. You can either call the function LDigit or find the last digit directly, but you're adding up the last digits of all the numbers in the array. All right. Okay, so let me see who can write that. It's okay to be wrong, but I want all of you to try it and write what you can. You're writing only the function that will receive, the name of the function is going to be LSUM, and it'll receive an array. Now, when you receive an array, you had to receive size, and it will return the sum of the last digits of all the elements in the array. Uh, Louis, you only wrote the header of the function. You had to write out everything so that the function will find the sum of the last digits of all the numbers in the array. You need to write out the entire function. Okay, I have one now. Christopher has sent me a solution, but you are adding all the numbers in the array. You are adding last digits. And also this statement inside the loop should be indented. Okay, indent the statement inside the loop, otherwise it's difficult to read. And make a change to that program so that you add up not the entire numbers in the array, you add up only the last digits.
Oh, okay, okay.
I'm waiting for other students to write.
Working on it.
Okay.
Can you can you go back to the last slide so we can reference?
Okay, previous slide, this. Yeah, it's going to be very much like this function add up with a minor change. Okay, it's one in the chat. Anissa, you're not adding up anything. You're not adding up anything. So there's a error. Try again. Okay, I have a solution from Terrence. I think you are using Y as a subscript, but you didn't write it correctly. Is the Y the subscript? Then why are you using a T in there and then X in the brackets? You messed up everything by introducing additional variables. You only need the subscript Y if that's what you have, that's what you want. You don't need the T and the X is the size. Okay, X has to be used as size, but what you have written inside the loop is wrong. The subscript of the array, you're writing X for it, which is wrong. Okay, Anissa says, can you have more than one array in one function? Yes, of course, you can receive more than one array. But in this case, we only need to receive one array. There's no need for two arrays, but two arrays can be passed to function. like I explained before, a function can use another function. So in this function you're writing, you can use the function called LDigit that we wrote before. You can use that function. So 4 of you made an attempt and I suggested changes. You need to do that. You need to write the new version and send it to me. Okay, I'm still waiting for this. Nothing complicated in this question. It's very similar to the example we went over with a minor change. And you have to try it, only if you try, you learn from it. All right, we're out of time, so I'm going to explain on the board. We need to write the function LSUM to receive array. So it's going to return the sum of the last digits, which is going to be integer. So my function is going to be int type. Return type is int. So int LSUM. And I receive int, and I'm receiving an array in the name A. So write a bracket. This is just a name I make up. And then int size. And inside, I need to declare a sum equal to 0, int sum equal to 0. And I need an I. You always need a subscript variable. For I going from 0 to I less than size, I plus plus, for all those i's, I need to add up last digits. So sum equal to sum plus L digit parentheses AI. When I is 0, A is 0, very first element of the array is sent to L digit, and L digit will return the last digit. I'm adding that to sum and putting back in sum. That's how you add up. Now, instead of L digit here, if you want to find the last digit yourself directly, then AI, ith element of the array, modulus 10. That'll be the last digit. And so that's it. The loop will take care of all of the elements of the array. When the loop finishes, you need to return sum. The sum has the sum of the last digits. Okay, all right, so that finishes today's topic, and we will, but we didn't finish this entire 6.3. 6.4. We'll proceed to do that in the next class. All right, enjoy the rest of the day. I will see you Monday, and you have assignment. A link is already there, but I'm going to add some problems to the link. So make sure to check the links later to make sure you have done all of the problems.
How many more homeworks we have left?
Take care, Professor.
Yeah, we have homework in the next section, 6.5 and 6.6, and that'll be it. 6.6 is our last section.
Okay, 6.6. Okay.
And the project I have added to the links is the last project.
Oh, there's another project. I thought there was a. So you said the other one was the last project.
No, that was not the last one. This one is.
Oh, okay. Another project. Okay. Gotcha. All right. Thank you.
Have a nice day, everybody.
All right.